Why do people keep saying that starting to invest early matters more than picking the perfect stock? And why can credit card debt suddenly feel impossible to escape? The answer to both is compound interest. Compound interest is one of the most important ideas in personal finance because it changes how money grows over time. It can quietly build wealth for decades or quietly grow debt in the background. First, let's define interest itself. Interest is either money you earn for saving or investing, or money you pay for borrowing. Usually, it's given as a percentage. If a bank pays 5% interest per year and you deposit $100, then after 1 year, you earn $5. You now have $105. That original amount, the $100, is called the principal. Now, here's the key difference between simple interest and compound interest. With simple interest, you only earn interest on the original principal. So if you invest $1,000 at 5% simple interest, you earn $50 every year. After 3 years, you've earned $150 total, so you end with $1,150. Compound interest works differently. You earn interest on the original money and on previous interest. People often summarize it as interest earning interest. Using the same $1,000 at 10% compounded yearly, after year 1, you have $1,100. In year 2, you don't earn interest on just the original $1,000 anymore. You earn 10% on $1,100, giving you $1,210. Then year 3 grows from $1,210 to $1,331. Notice what happened. The amount of interest grew each year because the balance itself kept growing. That's why compound interest is considered exponential growth instead of linear growth. The growth accelerates over time. Early on, it can look slow, but later the curve gets much steeper, almost like a snowball rolling downhill. Now the formula. The standard compound interest formula is A equals P times open parentheses, 1 plus R divided by N, close parentheses, raised to the power NT. It looks intimidating, but each piece is simple. P is the starting amount, R is the annual interest rate as a decimal, N is how often interest gets added each year, and T is time in years. A is the final amount. Conceptually, the formula is just repeated multiplication. Every compounding period, your money gets multiplied slightly. The exponent means that multiplication happens again and again over time. Compounding frequency matters too. Suppose you invest $1,000 at 6% for 5 years. If it compounds yearly, you end with about $1,338. If it compounds monthly, you end with about $1,349. The difference is real, but time and rate usually matter more than frequency. This is also where APR and APY come in. APR is the stated yearly rate. APY includes the effect of compounding. For example, a 12% APR compounded monthly actually grows by about 12.68% over a full year. Compound interest becomes powerful when combined with consistent investing. If you invest $200 every month for 10 years at 6%, you contribute $24,000 total, but the account grows to roughly $32,776. The extra money came from growth, not deposits. But compound interest also works against you in debt. A $5,000 credit card balance at 18% interest can grow rapidly if unpaid. The same force that builds wealth can also accelerate debt. 4 things mainly drive compound growth: higher rates, more time, more frequent compounding, and consistent contributions. Time is usually the biggest factor. A useful shortcut is the rule of 72. Divide 72 by the interest rate to estimate how long money takes to double. At 6%, money doubles in about 12 years. At 9%, about 8 years. Compound interest is ultimately simple. Money grows, then future growth happens on the larger amount. That repeated growth is why starting early matters so much.